We're going to do the most unusual of all of these structures, and what makes it unusual is that it has an odd number of electrons. Now, if you come up with an odd number of electrons, most of the time you're going to be incorrect. They almost always come out even because the odd ones are very reactive and they don't like to stay that way. But we're going to go ahead and do an example so that you know what they look like. This is going to be very little of the time that you'll be doing loose structures, so don't get all excited and try to give everything odd numbers of electrons. So we only have two atoms, so we have N and O, and then we're going to put a bond between them. So that was 10, and then now we're at 9 because of the electrons in that bond, and then 7, now we're at 5. I'm going to spread them kind of around. And then now we're at 3, and now we're at 1. And then what do you do with the extra electron? Well, you just pick a spot to start with, and instead of putting it as a pair, you just put it in one spot. Now, of course, you're probably thinking, well, why not put it on the other spot? And you totally can. So I'm going to go ahead and copy that one and do a version of it with the single electron on the oxygen. Now, there are rules that govern this. You're going to learn about in the formal charge section so that you know which of these structures really is the best structure, but for now you don't know. All right, so what we're going to do is we're going to take a lone pair. We can take it from this side and we'll draw a line there. And at least now this way oxygen has 8, and I know that nitrogen only has 7, but that's close to 8, right? You're probably thinking, well, at least that's close to 8. You can't ever go over 8. So get close to 8, you can't go over it. For these guys, remember you have the list of those ones that can do it. More than 8, but they're in the third row and below. And then we're going to do it the other way. If you remember, I'm going to copy. So those two electrons that were in that bond came from this side. So I'm going to make them come from this side. Now, if we pause and we look at this one for a second, there's actually is a problem. Nitrogen on this side has 1, 2, 3, 4, 5, 6, 7, 8, 9. It has 9 electrons around it, which is too many. And then oxygen has 6, which is too few. So this structure isn't going to work for us. So now we're going to look at the lower one down here. Now, as drawn, this oxygen is a little bit short, but so is our nitrogen. They both are a little short. So I'm going to try taking a lone pair. Well, we'll look at the lone pair coming over from the nitrogen first. I'm sorry, from the oxygen first. So if we do this, at least nitrogen has 8 in that case, and then 2, 4, 6, oxygen has 7. So at least in that situation, they're almost at 8. And then I'm going to copy that one over and show you. Let's see, paste. Those electrons, remember they came over from the oxygen over here. And if we try to bring the electrons over from the nitrogen like that, we're going to be stuck with nitrogen having 6 and oxygen having 9, which is kind of like the reverse of the problem above. So again, we can't do that one. But these two are possibilities. We're going to learn about formal charge, and we're going to see which one would give us the better formal charge. And one more comment. You might be thinking, well, why not go ahead and take this pair and pull it over and make a triple bond right there? Again, if you were to do that, that would give oxygen 9 instead of 7. So you can start pulling electron pairs over, but stop when they get to their max that they can be.